Hi, the topic of today's discussion is E is equal to mc square, the nature's unifying fact. This equation was given by Albert Einstein, and the whole crux of nature is contained in this relation. Let us see how. The nature manifests itself in two forms, energy and matter. Whatever you see around you, like furniture, walls, buildings, trees, mountains, or the food you eat, or the air you breathe, is all matter. And the sun rays, light, heat, sound we hear, and the signals we receive in our mobile are all energy. So all the physical entities can be classified under these two categories, energy and matter. Energy is something you can only feel, whereas matter you can see and handle it. Energy is made up of waves and matter is made up of particles. Wave is a disturbance traveling through a medium, as can be seen here. For the visualization of waves, the simplest example is the ripple formed on the stable water surface when an object is dropped on it. Basically, the kinetic energy of the object is transferred to the molecules of the surface, and that energy uniformly distributes in all the directions, forming these concentric circles, and this can be understood as surface waves. Sound is also a form of energy. Taking an example of a guitar, the vibrations on the guitar create density variation in the air medium, which travel through the medium in form of sound waves, and we are able to hear melodious music of guitar. And the energy received from the sun, light and heat rays, X-rays, microwaves, radio waves, or the waves for communication for TV and mobile are all electromagnetic waves. Electromagnetic waves are special type of waves which do not require medium to propagate. As it is clear from their name, in electromagnetic waves, mutually perpendicular electrical and magnetic field propagate along with the wave in the plane perpendicular to the direction of the propagation of the wave. Basically, waves are generated due to the oscillation of a physical entity about its mean position or a simple harmonic motion, the example of which is simple pendulum. And the waves generated by simple pendulum can be represented like this, in which these points represent the mean position of the bob, and one cycle of this bob can be represented as this part, and the same path is repeated again and again. So waves are described by its wavelength lambda and frequency f. Wavelength is the distance traveled by the wave in one complete cycle and is measured in terms of centimeters or Armstrong. Whereas the cycles traveled by the wave in 1 second is known as its frequency, and it is measured in cycles per second. The energy of the wave is proportional to the frequency and inversely proportional to the wavelength of the wave. Here h is the Planck's constant, which we will discuss later in this lecture. If F1 and F2 are these two waves, then we can see the number of cycles here is higher, means frequency of this wave is more and energy of the wave will be high. Means higher the frequency, higher is the energy of the wave. And conversely, the wavelength of this wave is larger and energy is less. Higher the wavelength, lower is the energy of the wave. Now here are some pictures of Republic Day celebration of India. Whatever you see in these pictures are all matter. And if somehow with a super microscope we can able to zoom into these objects, we can see that they are made up of small particles. Basically, matter is anything that takes up space, has mass and volume. Matter is composed of tiny particles like crystals, molecules and atoms. Material is described by its mass and velocity, and the momentum is the product of the two. Materialistic bodies are described by its momentum, which can be understood as a physical impact or thrust created by that body. Taking an example of truck and car having masses as mt and mc respectively, moving with the same velocity v. Now truck is a heavy body as compared to the car, so the momentum of the truck will be more, and if this will strike the wall, the impact created by the truck will be more. In this way, nature's two basic forms, that is energy, has wave-like characteristics and matter has particle-like characteristics. Waves are spread out in the space and doesn't have any specific position, and matter has unique position at particular moment of time, and that can be denoted by specific coordinates. This means both of the two are opposite in nature, means they are contradicting in their behavior. This contradiction of the behavior of the two basic forms muddled up with the discoveries in the early of 20th centuries, like Planck's explanation of black body radiation, photoelectric effect, which suggested that the light waves sometimes behave like a particle, and de Broglie hypothesis proposed that the particles can behave like waves in special conditions. To proceed further, we need to understand these two concepts. Starting with Planck's idea. In the year 1900, Max Planck, a German theoretical physicist, discovered energy quanta while studying black body radiation. The hot objects emit light, and the color of the light emitted is different at different temperature, and Planck was trying to explain the color of hot glowing matter and successfully explained this phenomena. He explained this with the postulate that energy is quantized and could be emitted or absorbed only in integral multiples of a small unit of energy known as quantum. This means energy is discrete. So energy continuous and discrete. What does this mean? In conventional view, energy is considered continuous. It can have any value from maximum to minimum. This can be understood with the help of an example of a ball placed at the top of a slope which is at height h from the ground. then the potential energy at this position of the ball can be given as mgh1. Here m and g are constant and h is height which is varying here, and the energy, potential energy of this ball will depend on h. Obviously on this slope h can have any value, so energy can have any value. But in quantum view, the ball can have only specific energies as seen here. The ball can have energy this or this much. If this is the minimum energy, we can say EQ, then the ball can have energy 1 EQ, 2 EQ, 3 EQ, 4 EQ and so on, means 2.1, 3.8, these energies are not allowed. This is known as quantization of energy and this is known as discrete energy. So before Planck, it was assumed that energy radiated from black body was continuous and that any value was possible, like a ball rolling down the smooth slope. And Planck proposed that energy is quantized and only certain discrete values are allowed like this. In 1905, Einstein took forward the Planck's idea of energy quanta and explained photoelectric effect. Photoelectric effect is the basic principle of solar cell in which light energy is converted into electric energy. When the light rays of sufficiently high frequency fall on the photosensitive surface, electrons are emitted. The working principle of solar cells can be understood with the help of this figure, in which the negatively charged electrons of photosensitive surface absorbs the light radiations and acquire energy, and this energy is used by the electron in escaping out of the surface and it reaches to the anode plate, and due to this transaction of electron, the potential difference between the two plates is created, which can be used for generating electricity. Basically, in explaining this photoelectric effect, Einstein considered that these light rays are made up of particles or energy of bundles and called them as photons. And with this assumption of that light is made up of particles called photon, he successfully explained the photoelectric effect. This was the equation which explains the photoelectric effect and was proved experimentally as well, and he laid down the laws of photoelectric effect on the basis of this equation, which were experimentally verified. So Planck proposed that the energy of light is proportional to its frequency and Planck's constant was introduced. Whereas Albert Einstein considered that the light is made up of particles which are known as photons, and these two concepts were game changer in this field of energy to matter and matter to energy conversion. Conventionally, energy was considered to propagate in form of continuous waves like this. In quantum view, energy propagation takes place in form of wave packets like this. And these concepts given by Einstein and Planck was revolutionary, and it gave rise to new branch of physics known as quantum mechanics. And the concepts were so important that Max Planck won Nobel Prize for discovery of energy quanta in 1918, and Einstein was conferred with Nobel Prize for its law of photoelectric effect in 1921. And this gave a new concept that the particle nature of waves, which means the waves may have particle-like characteristics and energy can behave like a particle. The revolutionary view of waves, that the idea of particle nature of waves was turned around by French physicist Louis de Broglie, who suggested that electron, the particle, can be described as waves. He used the analogy of symmetry in nature. Actually, physics says that nature loves symmetry, and certain kind of symmetry prevails throughout the nature. Taking an example of law of gravity, it is same for moon and earth as well as for sun and earth. The symmetry can be seen in the law of forces as well. The gravitational law of forces have this kind of expression, and the two masses attract each other, and the force between them is given by the product of the two masses and inversely proportional to the square of the distance between the two. The Coulomb's law of electric forces have this expression, which shows that the two charges Q and Q2 will always exert some force on each another, and the force will be proportional to the product of the two charges and inversely proportional to the square of the distance between the two. So these expressions also have some kind of symmetry. The symmetry can also be seen in the structures. The huge universal structures like solar system, we have huge sun at the center and planets revolve around this sun in elliptical orbits, whereas the smallest material particle, that is atom, also have the similar structure in which heavy nucleus is at the center and light electrons revolve around it in the elliptical orbit. On the basis of the law of symmetry, de Broglie theoretically hypothesized that as the wave behaves like a particle, there is a possibility that the particle may also behave like a wave, and the wavelength associated with the moving particle is called as de Broglie wavelength and given as the Planck's constant upon the momentum. The waves associated with a particle are called as matter waves. The wavelength is significant for very small atomic and subatomic particles only. It is insignificant for higher masses. According to de Broglie, the electron revolving around the nucleus in the atom behaves like a wave, as can be seen here. This wave-like behavior of matter was first experimentally demonstrated by Davison and Germer in 1927, and after its verification in 1929, Louis de Broglie won the Nobel Prize for the discovery of wave nature of electrons. So in this way, the waves behave like a particle and particle can behave like a wave, and this is called wave-particle duality. This concept means that the wave aspect and the particle aspects are complementary to each other. And it was so important that so many Nobel Prizes were won in physics in this period of discovery of this concept. Now, the perception about the nature's two basic entities, energy and matter, has changed. If it is a wave like this, we can have a particle associated with this wave like this. And if a particle is moving like this, the wave is associated by it. So this is a representation of wave-particle duality concept. All this can be concluded as the matter and energy are interchangeable, and the total amount of matter and energy in the universe remains constant. This concept leads to the Einstein's equation, where E is the energy associated with the mass m and c is the velocity of light, which is a constant 3 lakhs kilometers per second, and in this expression it is in square. It means this is a very large number. So if any process we are able to convert a small amount of mass, huge amount of energy is liberated, and this liberated energy is known as nuclear energy. Nuclear energy is harnessed around the world to produce electricity through nuclear fission. This energy doesn't emit greenhouse gas and is considered to be a clean energy. This fact is important in terms of generating nuclear power, which is clean and recyclable too. This emerged as a new source of energy for the development of the mankind. Here you can see the world's first nuclear powered ships named as Long Beach, Bainbridge, and Enterprise. These are US naval aircraft carrier vessels. In this, the crew members of Enterprise are spelling out Einstein's mass energy equivalence formula on the flight deck as a significance to commemorate the new source of power, that is nuclear power. This formation was done in Mediterranean Sea in June 1964. The importance of this equation and its implication to the development of mankind can be assessed with the help of such kind of gestures. We had started this discussion with the nature's two basic entities, energy and matter. We can see that now that they are equivalent and convertible one into the other. And this expression establishes that they are the two names for the same conserved physical quantity. The expression looks very simple, but it unifies all the entities present in the nature in such a small expression. In this way, it contains the essence of the whole universe. That is why we say the unifying facts has been discussed in this video. There are many more interesting aspects related to this expression, which I'll be bringing in some other video. By then, thank you for watching.